Learning objective B, we're going to do function composition to actually find formulas. And here's the difference. If you look at this example, they want us to find f of g of x, g of f of x. Instead of an x here, when we had the numbers, they maybe said 2, 3, or 4, and we would evaluate it. When they don't have a number here, but just a variable, it means find the formula. So let's just go ahead and get started. For letter A, they want us to find f of g of x. Now I'm going to show you two ways to do this. The first one is just, again, substitution from the inside out. Right here, I'm going to start on the inside, and they want me to find g of x. Well, I actually already know it. It's just this up here. It's x minus 7. So I'm just going to put that in its place. So I'm going to take out the g of x label and actually put what it is, which is x minus 7. So that means find f of x minus 7. Now be careful, this just says go to the f function. So notice here, the g function is gone. You will never go back to the g function up here. We've already embedded it in here and it's gone. You just go to the f function. So the f function is this guy right here. So now it says go to the f function. Wherever you see x, put this in its place. So I'm going to have to put it here and here. Well, that's going to give me 2 and then x minus 7 squared plus 3 x minus 7. Now, this is kind of a lengthy problem because we want to put it in standard format. Be cautious here. Don't just distribute the 2 to both. You have to repeat the base of x minus 7 twice. So I'm going to do that here. X minus 7, x minus 7. I'm going to go ahead here and distribute the 3 to both right now, though. 3 times x is plus 3x. 3 times negative 7 is negative 21. Now with these three terms, you can pick and choose what to multiply together first. I'm going to multiply these two together here first and just distribute that 2. So I'm going to get 2x minus 14, and then I have the x minus 7. And then don't forget the 3x minus 21 is still there. Let's come in now, and we are going to have to distribute those through, and then we'll simplify and see what we get for an answer. So we continue. 2x and x is 2x squared, 2x minus 7, negative 14 times x, and negative 14 times 7 is going to be a positive 98, then plus 3x minus 21. In standard format, we are going to get 2x squared. Then I have to add all these x's together, so negative 28 plus 3, negative 25x, add my constant values, plus 77. So that is the formula. Now they do want us to switch and do it for B. Let's switch the order. Now they want us to find g of f of x. Let me show you this one. Let's do it the same way. Let's substitute. If I know f of x, I'm going to plug it in there. I do know f of x. It's this value, that whole expression up there. So I'm going to replace f of x with what it is, which is 2x squared plus 3x. Now notice again, there's no more f of x here. Where does it tell me to go? It says go to the g function. So eyeball up here. So you're going to go to the g function. Where you see x, you put this. So I'm going to put it right there. So this would have been x minus 7, but this is x, so I put that in its place. And to simplify, this one's a piece of cake. 2x squared plus 3x minus 7 is our final answer. Let's do one more, and I'm going to show you a second approach you can take. This just skips one step, and you're more than welcome to use any of the approaches we talk about. Let's find f of g of x. So here's what I'm going to do. I'm going to skip one step and jump right to the first write-up. This says take g of x, so I eyeball g of x and know that it's this whole formula. I'm going to take g of x and plug it in wherever I see x in the f function. So I take this and I put it right there. If I do that, I can jump ahead, and instead of writing x squared, I can put this in its place right away. Now, I'm going to go ahead and, again, be careful, distribute this exponent to both. It's going to leave us with 1 squared over, in parentheses, 3x plus 1 squared. That's 1 over, you have to repeat this base twice, and then you're going to have to do the distribution on that. In your distribution, everything touches everywhere. So what we're going to get is 1 over 9x squared plus 3x plus 1. When you simplify, 1 over 9x squared plus 6x plus 1 is your final formula. Let's reverse the order, and I'm going to do that same trick this time on this one. They want us to find g of f of x. So that just says find the f function, which is right up here. Take that f function and go into the g function, and wherever you see x, you put it. So I take this and I put it there. So this is going to be 1 over 3, not x, but x squared plus 1. Simplify, you're going to get 1 over 3x squared plus 1. Much easier to simplify, and it is a different formula. Now, if you don't like this shortcut method, again, don't forget you can do the other one. Let me just show you the setup. I'm going to replace f of x with x squared. So what I would do is say find g of x squared. Now it says go to the g function, which is this here. Wherever you see x, put this in its place. When you do that, you will get this answer here. Now when you do function composition, they may ask you for the domain. So let's do a few examples. Here they want us to find g of f, and it looks like we're using the letter m here, so that's fine. I'm going to go ahead and do this. I'm going to actually find f of m and just put it in there, which is this. I'm just going to substitute it in. G of the square root of m. Now it tells me to go to the g function, which is here. Wherever you see m, put this in its place. So I'm going to rewrite it as 2 over the square root of m minus 3. Not much to simplify here, but they are going to ask us to find the domain. Remember, the domain means what can x be or not be. A lot of the times you'll say it's all reals, or you'll say all reals except. In this case, you have to be careful. The bottom of this fraction can never total 0. So what you're thinking is this: the square root of m minus 3, when it equals 0, I have an issue. What's going to make that happen? Well, if you solve this equation, you'll get the square root of m equals 3. To get rid of the square root, all you're going to do is come in and square both sides. So it looks like when m is 9, we might have an issue. Let's think about that. Is that the case? If I put a 9 in here, you'll get square root of 9 is 3. 3 minus 3 is 0. So here's what we know. M cannot be 9 for sure. This is part of our domain. Now this one is also a little bit trickier because we do have a square root. Under the square root symbol, you have to be cautious. We can't have negatives. So the lowest this number can go under m would be a 0. So here's what I would say. The domain is all reals greater than or equal to 0, excluding the number 9. You also, if you wanted to write this part here, instead of that, you could say x is greater than or equal to 0 and say excluding the number 9. This is actually a pretty complex domain problem. It's great because it covers both that you can't have a negative in the square root, and it covers that we cannot have the number 0 in the bottom of the fraction. The last one here is just going to challenge you not to oversimplify. They want us to find g of f of m. So I'm going to do the shortcut on this one. I'm going to take f of m, which is this, and plug it into the g function, which is right there. So I'm going to get not m to the 4th, but the square root of m to the 4th. Now you're going to be tempted to want to do, if you know your square roots, that's the 1/2 power. If you remember from Algebra 2x, you're going to want to say possibly it's m squared. You have to be careful, that's not true. I would keep the equation in this format because If you look at what I wrote in the blue here, this is a parabola. There's no domain issues. X can be anything, or in this case, M can be anything. So letter B, which is a wrong answer. This is not the simplified equation, and M can't be anything. You must keep it in this format because the square root in there is causing a limitation. Remember, we can't have negative numbers under the square root. It can only be 0 and higher. Therefore, we're going to keep the function looking like this. We can put the number 0 in there or anything more positive. So C is the appropriate domain for this function. So the key here is when you do function composition, sometimes when you oversimplify, you actually change what the graph is. Be careful.